Hi. Hi everyone. A very warm welcome to our day 5 session of Array and String Mastery series by Aarush coaching classes. So today we will be learning about the sliding window pattern. Okay. We will learn about why we need it, how to implement it, and try to solve one or two problems on it and then gradually move towards the advanced concept of variable sliding window pattern. Okay, so today we are going to talk about mostly about the fixed sliding window. Okay, first I want you to understand the idea, okay, implement it, absorb the whole logic, and try to understand when and how to apply it. Okay, so let's start with this sliding window thing. Okay, so what is sliding window? So if any of you know about it already, you can write in the comment quickly. Or anyways, I am gonna teach you and make you understand by explaining it properly about how and what it actually is and how it works. Okay. A simple analogy, if I were to tell you about this is, imagine a fixed size window. Let's say this is a window. Window means, as the word says, sliding window. So don't imagine वो घर वाला normal typical window whose door opens one this side and one this side. Okay. Instead, think of the sliding window. है ना? So though you can, if you can just visualize this kind of the glass sliding window, na? Usually it is made up of glass or glass is there. So at a time, you can either open this side or this side. Okay, the window is and this whole, you can say, design is divided into two equal parts. One side, if you slide the slider here, then this part of the window is opened, and this particular part is visible to you without the glass. And if you slide it here, then this particular part is visible to you. Okay, if you slide both. Okay, so somehow, not exactly, but somehow similar to this is what we are gonna look at today and apply it on our already learned data structure. Okay, this is just simple thing, not the complete thing about this window. Now let's read it again and try to understand the rest of the parts. Okay, so imagine a fixed size window sliding over an array. Let's say array. This is an array. Okay, one item, two item, three, four, five, six, seven, 8, 9, 10. Okay, yeah. What our items are. So if this is size of window, okay, sliding over an array, look at different sections without starting with each time. What this line tells you about, don't worry right now. Okay, just imagine this diagram for now and don't worry, you don't even need to think about key, what are we trying to achieve by this. Okay, just stay with this visual. Okay, rest I'm gonna explain. Don't worry. When do we use a sliding window? So problem asking for subarray. So please try to remember the keywords. These are gonna be hint for you. Subarray or substrings, maximum और minimum sum of size k. है ना? जब size भी defined हो, okay, और subarray की बात हो रही हो, then count occurrences in windows. Okay, again window की बात हो रही है, fixed size की. Fixed size window problems where it can directly be mentioned. Okay, so this was for the starters. Now what is the idea behind it? Okay, because so the idea is instead of recalculating everything, reuse the previous computations. What does it actually mean? Reuse the previous computation. Let me set the context for you with a simple example. Think if you are counting people in a moving bus. Let's say you have a bus. Okay, you have a bus. ठीक है मान लेते हैं this is a bus. Okay, this bus is gonna travel from station 1, bus station 1, then bus station 2, bus station 3, bus station 4, and so on. ठीक है, Now, at every bus station, you want to know total count of passengers or people in the bus. What you would be doing? Okay, this is a problem statement. So just think about it. What you would be doing then? Most basic thing is first you would say so. What I will do is okay, at station one I will count all the people in the bus at every station. Yes or no? Correct. If you agree with me, then you can write yes in the comment. If no, then you can write no in the comment. Okay. So the basic idea would be what most basic thinking ways ki you will try to calculate all the people in the bus at every station. Let's say at a station number one, when this bus reaches, you'll say, sir, you will count everyone and you'll say 50 people are there. 50 people. Okay. Then moving forward, when bus reaches here, station number two, okay, then you will count again and you will say, now there are 47 people. Correct? 47 people. You will count again at station number three and you will say 60 people. Again, bus moves station number four, you will say 70 people. Okay, and so on. Correct? I will count all the people in the bus at every station, है ना? From scratch, ऐसे लिख लेते हैं for better clarity. From scratch. My question is, do I really need to do this? Because as you know from the practical life, you know that not at every station all the old people, older people, old means all the previously onboarded people leaves the bus, reboard it, and completely new people onboard it. ऐसा होता है क्या? Does it happen? नहीं, सिटी बस में नहीं होता है. So that means that note not every one leaves the bus at a particular station. Instead, what happens is at every station, X number of people leave and Y number of people on board. Yes or no? ऐसा होता रहता है usually. So my question is, do I really need to calculate every time from scratch? है क्या? Answer is no. Because I can find the repetition, है ना? Repetition. I can find the repetition in the job. Yes or no? In this job. What is the kind of repetition? The repetition is the people who have already onboarded from station number one are being counted again at station number two, and some of them are still being counted at station number three and four, and so on. So, what basically I can do is at this very first station, I can just count once all. ठीक है, सबको काउंट कर लिया. Let's say 47 50 people हो गए. ठीक, at S1. At S2, I know previous station पे 50 people थे. So let's say the people who are living is X and people who are onboarding is Y. So total count कितना हो जाएगा? Previous sum minus X plus Y will give me total. Yes or no? Yes or no? I just need to know that कि कितने चले गए and कितने add हो गए. Same for station number 3 also. Previous sum minus x plus y equals to total. Now you can see that too much of the repetition or repetitive work have been already eliminated. Yes or no? है ना? Yes or no? So this idea is what is, you can say, the gives you the basic logic behind how sliding window works. We avoid repetitions or recalculations, okay? Instead of recalculating everything, we try to reuse previous computations and reach our objective, okay, and achieve the solution. Okay, I hope this is clear till here. How do we avoid recalculation? Our basic, or you can say major focus is upon avoiding the repetitive task here. That's how I mean, that's the only way we can optimize it, and that's the only way, and that's only why sliding window comes into play to optimize things. Okay, so let's see. Let's try to understand in a better way with a particular problem. Let's try to look at this problem. Okay. What is this problem? The problem name is maximum average subarray. Okay. The statement says find the contiguous subarray. Contiguous means, if you remember from the very first class, I showed you that arrays memory space allocation in the memory is in a contiguous way. एक के बाद एक आता है, continuous उसमें आता है. Okay. Continuous format में होता है. Okay, so here find the contiguous subarray of given length k, length is also given, that has the maximum average value. Okay, so here in the input example they have given nums. Okay, nums is the array where there are 1, 2, 3, 4, 5, and 6 items. Okay, and they are given the window size of 4. That's a window. Okay, length k is given already. Subarray of k. So k is a size with which we need to look on the array. Okay. Now, array is given, size is given, output is 12.75. But how did we reach here? So let's see. K is 4 now, and they are saying subarray of given length k that has a maximum average value. Means that for every subarray of size k, we need to find the average sum and then print the maximum among all in the output. Okay. So subarray, for an array, subarray can be too many, of size 1, 2, 3 till n. There are too many arrays possible, subarrays possible. But here it is specifically given subarray of length k. Here, which is 4. So first tell me in the comment how many such subarrays of length k, or sorry, length 4 is possible for this particular array. So let's see how many subarrays are there. So subarray 1 would be 1, 2, 3, and 4. 4 items. 4 items are there. 1. Focus upon this contiguous subarray. That's what they're talking about. Okay. So 1, 12, minus 5, and minus 6. What would the subarray 2? Subarray 2 would be from here till here. Okay. So 12 minus 5 minus 6. Or instead, let me write it like this: 12 minus 5 minus 6 and till 50, right? Till 50. This is my S2. What is my S3? S3 would be subarray 3 would be till here. Okay, so minus 5, minus 6, 50, and then 3. Is there any more subarray of size 4 possible? If I start from 6 minus 6, I can't go any further because there is no more item, correct? So I can't go any further. I can't have any more subarray of size 4 here, which is contiguous in nature. Okay, so here you can see that 3 subarrays is what we have. If I were to calculate the sum, if I were to calculate the sum, कितना आएगा? 12 plus 1 13, correct? And 6 5 11, 13 minus 11 2 हो जाएगा, correct? Sum would be 2. Let me write it here. What would be the sum? So if you look at this, if you look at this, what would be the sum? Sum would be 12, and this is minus 11 and 50. 12 minus 11 1, 50 plus 1 51. Okay, here the sum would be minus 11 and 50 and 3 53. So it would be what? It would be what? 51 minus 11. Sorry, 53 minus 11, 42. Correct? Sum would be there. Now average. Average would be what? Average would be what? Sum divided by total number of items. So 2 by 4, 51 by 4, okay, 42 by 4. Correct? That's what it would be. So now here you can see this average would be 12.75 here. Here, यहाँ क्या जाएगा? 10.8 I think. 10.5 I think. Something, है ना? And here also it would be 1.2.5 हो जाएगा. Okay. So this is what it is going to look like, and the maximum is 12.75, which is answer. Here I want you to take 10-30 seconds, observe this particular part, okay, and try to find some pattern कि repetition कहाँ हो रहा है. Otherwise, anyways, in the moving forward, I will show you. But I just wanted to give you an idea कि क्या हो रहा था. But for the brute force way, just for the sake of solving this particular problem, what approach we can think of? What approach we can think of? What approach we can think of is a brute force approach where what we can do is we can start from here, okay, and some of the first k items, which is 4, so 1 2 3 4, ठीक है, यहाँ से निकाल लिया some of the first k items, okay, then find the average and store it in the, like, see here. So what we will do, we'll find the first four items sum, 1 12 minus 5 minus 6 सम आ गया, ठीक है, 2 आ गया, एवरेज 0.5 आ गया. Will store average for मैक्सिमम वैल्यू, ठीक है. अब जो भी नेक्स्ट एवरेज आएगा उसको कंपेयर करेंगे विच प्रीवियस एवरेज एंड करंट एवरेज, एंड देन विच एवर इज मैक्सिमम विल स्टोर इट. ओके, आई होप यू ऑलरेडी नो दैट लॉजिक, वी हैव बीन वर्किंग अपॉन इट फ्रॉम द प्रीवियस क्लासेस. ओके, सो फर्स्ट ये करेंगे. नेक्स्ट क्या होगा? नेक्स्ट फिर अगेन विल ट्राई टू स्टार्ट फ्रॉम हियर, कैलकुलेट. सो अगेन सेकंड, फॉर द सेकंड विंडो दिस इज द सिंबॉलिक वन. ओके, सो 12 से स्टार्ट किया till here. Okay, then the sum was 51 and average 12.75. इसको अपडेट किया मैक्स में, तो 0.5 पहले था उसको हटाया and we will be putting 12.75. Okay, after that what will be putting? फिर we'll move to next window, means my iteration would be starting from here till here. Okay, so now what? Again, sum is here, average is 10.5, which is less than 12.75, so I am not going to update. So after that, can I do more iterations over this array to find the sum of k contiguous items? Yes or no? नहीं. अब यहाँ सिर्फ 3 items बचे हैं. So no, I can't. So till here, once my iteration is over, I am getting 12.75 only. So हम क्या कर रहे हैं? We are taking a for loop. I को 0 से start किया है, ठीक है? Because what is the indexes? 0, 1, 2, 3, 4, and 5. For I equals to 0, I should be less than what? कहाँ तक जा रहा है I? K size is I is going till index 2, and K size is 4. Can we find some relation if n is equals to 1, 2, 3, 4, 5, 6? N equals to 6, nothing but length of the array. Yes or no? Can we do this? Can we find the relation? You want check करके देखते हैं. Usually, if you want to traverse till the last, we what do we put? I less than n. But how many items are we leaving till the last item? कितने items छोड़ रहे हैं? 1, 2, 3, है ना? Which is 1 less than k, है ना? तो पहले less than n लिख देते. अब क्या लिखेंगे? Less than n minus k. Because less than 1 means not just less than n. Sorry, less than n means equal to n minus 1. So less than n minus k means कहाँ जाके स्टॉप होगा? n minus k minus 1 पे स्टॉप हो जाएगा. ठीक है, वहां स्टॉप हो जाएगा. दैट्स वाई इफ यू आर पुटिंग लेस देन, सो पुट n minus k. ओके, n minus k पे कर जाओगे. बट बट व्हाट डज n minus k गिव्स यू? अभी तो ये 3 है ना. लेट्स ड्राई एंड चेक. व्हाट इज n minus k? 6 minus 4 equals to 2. तो I less than equals less than 2 हो रहा है फिर तो. n minus k is giving me less 2. So less than 2 पे कहाँ तक चल पाएगा? I less than 2 means maximum value I can achieve is 1 only. But we need to go to 2. So क्या करना पड़ेगा? एक equal to भी लगाना पड़ेगा. Okay, एक equal to भी लगाना पड़ेगा. I less than equal to n minus k. Or I can write I less than equals to n minus k. Okay, to achieve this one extra part. See, you can, when I directly show you the solution, you can ask me, sir, ये formula कहाँ से आया? How would I know why to calculate it in this way? So there's no separate mathematical chapter to teach you these things. You know, these are basic addition, subtraction, division, multiplication thing. It's just that you need to figure out what you really want by looking at the screen or by looking at your, you can say, drawing thing. Okay, so that's why I try to explain it to you in this way. कि I could have directly said n minus k say less than equal to कर लो हो जाएगा. But then you will always be hanged with that question. How? सोचा कैसे आपने? है ना? वो part आता है. So I'm showing you exactly how you can think. है ना? यहाँ पे you need to find this pattern. K की वैल्यू क्या है? Because everything is numbers here, है ना? N की वैल्यू 6 है, K की वैल्यू 4 है, and because the window is of size 4, so you can't go beyond index 2, because after that you have only 3 items, so you can't go there. So this size of the window is certainly impacting till where you can iterate in your array. Yes or no? अगर ये size 3 होता है, let's say it was k equals to 3. So obviously you could have gone to index number 3 as well, because you are still having 3 items. उसके आगे नहीं जा सकते थे. So that's how it is impacting. You would have to hit and try in this particular way. And then only you will find out कि ये क्यों लिखा हुआ है. Okay. So I hope it is clear here. So I should be less than equals to n by n minus k, then I plus plus. इतना हम चला रहे होंगे. Okay. हटा देता हूँ, otherwise you will be getting confused. Now, find the sum. Sum would be what? Sum plus equals to, initially sum is 0, item I. Okay. ये चल रहा होगा, ऐसे चलेगा क्या? नहीं. Because this way you can do what? बस एक बार क्या ही आप इसमें सारे आइटम्स निकाल पाओगे, है ना? बाकी जगह तक नहीं जा पाओगे. Yes or no? So this was for this particular thing. एक 1 से start होगा, एक 12 से start होगा, एक -5 से start होगा. But still, these are the starting points, not the sum points. है ना? यहाँ से you need to calculate the sum of k items. So instead of doing this, you will just put sum equals to 0 and put for j. J would be starting at the place of I. Okay, j is equals to I. J is less than k. Here you can write, okay, j is less than k because k is the number of items we are calculating sum for, and j plus plus. Here, sum plus equals to array item at j. Okay. And then you'll be doing what? Obviously, sum निकल गया तो अपडेट एक मैक्स सम ले लो. लॉजिक क्या होगा वो बताएंगे मैक्स सम का, बट इनिशियलाइज विद समथिंग. हाउ टू इनिशियलाइज आई विल टेल यू. ओके. सो मैक्स सम, सॉरी मैक्स एवरेज लेना पड़ेगा. मैक्स एवरेज, ओके, इज इक्वल्स टू मैक्स ऑफ मैक्स सम comma sum divided by k. ठीक, this is a rough formula. Okay, that's what you can do. आप ये कर सकते हो. और you can just directly do what? इसको max average ही रखो without making it complex. Max average ये आ गया, ये ब्रैकेट यहाँ ना करके बाहर लगा दो. ठीक है, that's how you can do. That's a pure mathematics. So now you can see that what are the iterations. यहाँ पे iterations कितने हो रहे होंगे. This inner for loop is running for k times. ये big of k ही चल रहा है हमेशा. And outer for loop कितना चल रहा है? n minus k times, which is similar to order of n only. Because k एक छोटा वैल्यू यूज लेता है, n की वैल्यू बहुत बड़ी हो सकती है. n can be of the order of 10 power 9 and k तो भी बहुत छोटा होगा, smallest, है ना. इतनी बड़ी विंडो थोड़ी रख सकते हो आप. इवन 10 power 9/2 का विंडो भी नहीं रख सकते आप. ठीक है. सो दैट्स वाई. सो टोटल टाइम कितना आ रहा होगा यहाँ पे. टाइम कम्स टू big of n multiplied by k. ओके, ये आ रहा होगा. नाउ लेट्स सी. ये इसका डायग्राम था कि at every loop what we are doing. Now look at the code. Okay, nums array is given, integer k is given. Double we are taking because doubles shows the, you can say, decimal numbers. So max average we are already declaring a variable to store the maximum average. And what are we putting here? Integer dot min value. Okay. So though it is different data type, so point 0 something would automatically be given there. Don't worry. Or you can directly give it. Now, here, first loop, outer loop, int I equals to 0, I less than equals to nums dot length minus k. Nums dot length is nothing but n, okay? I plus plus. Sum I have given 0, then j equals to I till j less than I, and then j plus plus, okay? J I plus k. Yeah. Okay, I think there is a calculation mistake by me here. Why? Because I से चलते रहा होगा k when I is 0, that is okay. But when I is equals to 2 na, or I is equals to 3, then this won't work because k is a constant number. So if you can see, 0 से start किया था, k का value 4 था, तो 0 till 3 it is working properly. But when my j is at here, so my k is still 4. So 1, 2, 3, है ना. And k 3 से j जो होगा k के पहले तक ही चल रहा होगा. So one item is what I am missing here. So again, here also I need to figure out a pattern of for this formula. कि what should I put here such that it will be working for rest of the windows as well, है ना. So that formula would be nothing plus I plus k, because j is increased by I, है ना. I 0 था, j 0 start हुआ, I plus 1 होके 1 पे गया, j भी 1 से start हुआ. So if j is initialized by I, j is initialized with I, so add I with k as well. Okay, so that's why this will become I plus k. Okay, so that's why when j was starting with 1, I am going till where? I plus k. I plus k would be 1 plus 4, which will be 5. And it is less than, है ना. So कहाँ तक जाएगा? Less than. I plus k means 4 तक maximum जा सकता है. From here till here. Now this is working properly. So that's why we will be putting here j equals to I, j less than I plus k, and j plus plus. we'll be calculating sum properly. Then after that, we are calculating the average value and then updating in the maximum average. Okay. And once this whole show is over of calculating the average sum in every window of size 4, we will be returning whatever is stored in the max average. Okay. I hope this is clear. And I have already explained why this is the time complexity. So this outer for loop is running for what time? Big of n minus k तक ही चल रहा है ठीक है which is equivalent to big of n only, and this inner for loop is running for big of k only. So that's why time complexity would become big O of n multiplied by k. In space complexity, though we are not using any extra space here, which is of the size of the order of the input, so big O of one only constant space आ गया. Okay, I hope this is clear. But again, can you optimize this? Because ये तो ठीक है, but this is extra. k की वैल्यू बड़ी होगी, this time would become bigger also, है ना? So let's see what we can think about, है ना? So key observation क्या है? Consecutive windows share k minus 1 elements. Let's reuse the computation. As I told you earlier, to do what? To figure out some pattern. Now let me show you that pattern. यहाँ देखो. For the very first iteration, we were adding all the 4 items है ना ये items हम ऐड करते 1 2 3 4 items सब निकालते किया था second iteration में are not we calculating you can say though we are calculating the sum of 4 items but are not we recalculating something if you can see what is the overlap here इतना तो overlap है overlap of 3 items yes or no. Even in the next iteration also, though we are calculating the sum of the next 4 items, but if you look at the overlap, how many overlaps are there? How many items overlap? Again 3 items. Means for every iteration, if I can show you, for every iteration or successive window, what is happening? There is only one item leaving and one item being added. Rest k minus 1 items are already there as they were in previous window. Yes or no? People, think about it. कितना overlap है? K का size 4 है, right? 3 का overlap है. Here again 3 items are getting overlapped. That's why k minus 1 items are already there. So why are we recalculating their sum again and again? Don't you think? It isn't making much sense, correct? First, in the very first window, we were supposed to calculate and we calculated. That is completely okay. But for all the successive window, we can clearly see that k minus 1 items are just repeating, nothing else. Only one item is living here. For the second window, this fellow from the 0th index left and this fellow from the 4th index is added. Here again, fellow from this first index is left and fellow from this last index is added. Yes or no? ये तो हो रहा है. So that's why what we can do is यहाँ देखते हैं. Consecutive windows share k minus 1 elements. That's what I was talking about. Our consecutive windows share k minus 1 elements. Okay, so let's reuse the computation. How to use it? Let's see here. Window 1 क्या करी थी? 1 12 15 minus 5 and minus 6 था, 2 आया था. Window 2 में instead of recalculating 12 minus 5 minus 6 50, just remove this one fellow and add this 50 fellow. Why? Because in the previous sum, we have retained the sum of these values. Yes or no? ये values तो हमारे पास retained ही है. Can we see this or not? Correct? 12 minus 5 minus 6 तो already थे वहां पे. So what we can do is new sum would be equals to, this is my previous sum, है ना? Item leaving and item added. That's what we are gonna do. So current sum equals to previous sum minus numbers at left, इसको left मान लेते हैं and इसको right मान लेते हैं. That's why don't confuse it with the left and right from the two pointer thing, okay? This is not, don't confuse two pointer. This is left item which was left, which was leaving the window, and this is the item in the right which is being added in the window. Okay, so this is the mathematical formula which enables us to avoid recalculating, instead subtracting the item which is leaving my window and adding the item which is coming inside my window. Okay, so this is the whole logic. This is how we can avoid recalculating. Let's see this in action now. Okay, so let's have this properly. Let's see this completely in action. यहाँ देखते हैं अभी. Here I have put the whole triangle for this. Let's see. My first window. Initially, I would have to take the sum of all the items in my first window, I know, because this is a beginning. So that's why index 0, 1, 2, 3, all items sum is 2. So max sum अभी 2 हो गया and sum अभी 2 था, ठीक है? तो अभी क्या करेंगे? Now, when I slide my window to the right hand side, now if I slide my window to the right hand side, you can see that this item is leaving my window and this item is getting added in my window, है ना? अब इस पे बात करते हैं. So what do we do? Remove nums 0 means the item at the 0th index, which is 1, okay, and add item at 4th index. Why? Because we have started working in this way. We are avoiding recalculation, है ना? That's why we'll remove and we'll add. तो क्या करेंगे अभी? New sum equals to, this is a previous sum 2 minus 1 plus 50, which is 51. Correct? 51 मिल गया. Max sum would be, previous sum was 2, previous max sum was 2, so max of 2 comma 51. So 51 would get updated here. Now in this window, the items were 12 minus 5 minus 6 and 50. Correct? यही थे. उसका मैक्सिमम सम मुझे यहाँ मिल गया. Don't worry about the average. It's just a matter of time. You need to divide it by the value of k. Okay. So let's focus here. Step 3 क्या होगा? We are moving to the next window. Once I move to the next window, what is happening? This item 12 is leaving and item 3 is being added. You there? Yes or no? अब अगर मैं यहाँ पे विंडो साइज बढ़ाता जाऊँ, let's say इसको 25 ऐड कर दिया items को. If I add items 25, 15, 9, 8, and I'm just showing you the extended version of this array. Okay, 6, 7, 8, and 9. So again, क्या होता जाएगा? फिर अभी वहाँ आया था मैं. Then I will go here. Then I will go from here till here. Then I will go from 31 to 9. Then I will go from 25 to 8 because window size is this much only. So every successive window, one item is leaving the window, one item is being added in the window. Correct? Why I have showed you this diagram? There's a deeper meaning because this will, only realizing this image into the code would give you the complete solution. That's how easy it is gonna be now. सब कुछ तो हो गया, है ना? So step 3 you can also see from here. Index 1 के item को delete करना है for the next window and index 4 के item को हमें add करना था. Okay? इंडेक्स 5 का आइटम को ऐड करना था. सो 51 minus 12 plus 3, 42. Maximum still 42 is smaller than 51, so 51 would be, and window is this. So that's how we are achieving our with this value, the number. Now how to do this? So just look at the image. First iteration you are complete calculating whole, you know. So step 1, क्या हो जाएगा? फॉर I equals to 0, I less than k, I plus plus, ठीक है। सम प्लस इक्वल्स टू नम्स आई कर दिया, ठीक। ऐरे कर दिया, नम्स कर दिया, कुछ भी नाम दे दो आप, इसको नम्स दे दो यहाँ पे, ठीक है। दिस विल गिव यू व्हाट? दिस विल गिव यू सम इज इक्वल्स टू 2, ठीक। ये आपको क्वेश्चन दे दिया। नाउ व्हाट? If you look at the screen very carefully, you don't need to recalculate. Instead, you just need to add this next item in the window and remove this very beginning wala item from the window. So what I can do? Now let's put a mathematical pattern here. If and because you can see only this whole four items were added at the very beginning. For the rest of the windows, all the successive windows, only one item is adding up and one is getting removed, one addition and one subtraction. So क्या कर सकते हैं? So isn't it looking like the iterations are done for what? To do the repeated task. What is a repeated task now? Here the repeated task was to calculate these four items, add four items. Here the repeated task is adding one item, removing one item, adding one item, removing one item, adding one item, removing one item. Correct? So let's start our iteration from here now on. यहाँ से, which is actually equals to k, the indexes. So for I is equals to k. ओके, ये कहाँ तक जाएगा? फोर से हम कहाँ तक गए? लास्ट आइटम तक गए, है ना, टिल द लास्ट आइटम। सो आई लेस देन एन, आई प्लस प्लस। ओके, नाउ दिस पर्टिकुलर थिंग, अब हम सम के लिए क्या लिख सकते हैं? सम के लिए क्या लिख सकते हैं? प्रीवियस सम, नेक्स्ट सम, करेंट सम, ऐसे करके कर सकते हैं, ठीक है। यस और नो? यस और नो? सो इसको क्या करेगा ना कि करेंट सम is equals to current sum equals to sum प्लस, प्लस क्या क्या, जो kth आइटम है यहाँ पे आई वाला आइटम, ठीक है। सम प्लस nums I. What is the index of this item? Though I know this is 0, but you can see every successive window we are removing the item from the beginning. So एक mathematical pattern क्या हो सकता है उसका? Mathematical pattern would be what? I am at this index, from here value of I need to derive the index of this value because I'm adding it and removing it. So how many items backward it is? How many items back it is actually? कितने items पीछे है ये? I minus 1 would lead here, 2 here, 3 here and 4. Exactly the value of k. So I minus k is leading me till here. Correct? So what I can do is, this is not supposed to be plus, this is subtracted nums of I minus k. This is how you are gonna get the current sum. Okay? Current sum or sum, whatever you want to call it. ठीक है, अब एवरेज भी निकल सकता है। मैक्स एवरेज इज इक्वल्स टू मैक्स ऑफ मैक्स एवरेज, इसी को आगे देखे मैक्स एवरेज इज इक्वल्स टू सम डिवाइड बाई के कर दिया, ठीक है। मैक्स एवरेज कॉमा सम डिवाइड बाई के, जो भी मैक्सिमम होगा मैक्स एवरेज में ऑलरेडी अपडेट हो जाएगा। So that's how you can do this, correct? Look at this. Same thing is happening. So what I am doing here is, step 1, calculate the sum of the first window. I have done it in the window sum. Okay, I0 till k, I plus plus window sum plus equals to nums I. Max sum को मैंने max sum ही रखा है, or I mean you can calculate the average in between or at the end also, doesn't matter, same answer would be there, because anyway to find the average you just need to divide it by k. Step 2, slide the window. So I is equals to k से हम start कर रहे हैं, I less than nums dot length last item तक जा रहे हैं, then remove leftmost element and add the rightmost element. So window sum equals to window sum minus nums of I minus k and plus nums of I. Okay, then maxim is getting updated equals to math.max of maxim comma window sum. That's all. And once you have calculated the maxim, at the end you can just directly return maxim divided by k, because sum max है तो average भी max ही होगा, है ना? Sum is max, average would also be max, because एक constant number से आप divide कर रहे हो, so it doesn't matter, it also be max. So I hope this is making sense to you. Now for the time complexity, अब क्या कर सकते हैं? Time complexity क्या होगी? Look at the screen and tell me. Please take 5 seconds and tell me the answer in the comment. What would the answer here for the time complexity? See, this particular loop is running k times, correct? And ये loop कितने time चल रहा है? N minus k times. K is constant value जो कि small ही होगी compared to n. So can't I say big O of n only time? Yes or no? And space, we are not doing much on the space. Why? Because we have not taken any extra space which is of the order of the input size of the array. We have just used few variables, you can say. Okay. So time complexity is big O of n. Space complexity here is big O of one on constant. Okay. I hope this is clear to you. So let's have a look at the complexity comparison. So for the brute force, n multiplied by k, n by k is, I mean, nk is the order of time, big of time complexity, nk, and then space complexity would be constant. You can think of it as, though I have taken the small value for the n, so n is 1000 and if k is 100, so this much operations, 100,000 operations is taking, but with sliding window, it is getting reduced significantly. Okay, order n, order 1, and 1000 operations only. Correct. So that's what it is. That's how it is getting optimized. That's how it is making it faster. So 100 times faster for this example, you can say. So this is how the sliding window impacts the solution. I hope this is clear to you. Some magic is happening and you can just feel it, right? कि तो काफी easy होता जा रहा है अभी, है ना? Okay, so let's move forward to one more similar kind of problem I have taken for you to practice, because it is the very first day of the sliding window. So I don't want you to push much. First, you need to take small bits to absorb also. So let's practice it, the same concept on one more problem in a little different way. What this problem is saying, let's read it. Given an array and a target value, count how many times a target appears in each window of size k. Okay, one array is given to you and a target value is also given. Now count how many times a target appears in each window of k, size k. Means still you need to work with the fixed size window. You just need to check how many occurrences are there of a target value in that particular window. That's why the problem name is count occurrences in window. Okay, I hope this is clear. Like you can see here, for this nums array 1, 2, 3, 2, 2, 1, 2, number of items is 1, 2, 3, 4, 5, 6, 7. So I can say n equals to 7, and you can directly get from the array.length or nums.length. Okay, window size is 3 and target value is 2. So you need to count the occurrence of 2 in every window of size 3. Okay, so output would be what? Let's see here. Give 1, 2, 3, 2, 2, 1, and two other items. And k equals to 3 is the window size. So how many such windows are gonna be there? One window, two window, three window, four, and five windows only. And that's why window 1, 2, 3, 4, and 5. Now, in the very first window, how many two are appearing? Just so एक बार आ रहा है यहाँ पे, two, correct? Only one time here, so that's a one time. In second window, two times, so two times. In third window, two times, so two times. In fourth window, two times and two times and two times, है ना? यहाँ पे भी two times and two times. Correct. So that's why the output is in the array 1, 2, 2, 1 and 2. 1, 2, 2. 2 and 2. Okay, just a minute. Maybe this output is not correct and we can correct it. No issues. Some typo is there. Let me just correct it. Yeah. So the output would be 1, then 2, then 2, and then 2, and then 2. है ना? सारे के सारे 2 1 एक भी नहीं एंड में नहीं आएगा यहाँ पे 2 रहेगा. Okay, I think now it is correct. Yeah, sometimes a typo happens, but yeah, we're humans and we can correct it anytime. Okay, so let's move forward. This is how you are gonna do this. So first thing is brute force. I don't need to tell you ना, आप ये कर ही लोगे. Every items you can, from every item you can start, है ना, till the three items, till the three item, till the three item, till the three item, till the three item, and you will get it. So brute force approach, calculate occurrence of target in every window. तो कितना टाइम लग जाएगा? Obviously, big of n multiplied by k, because from every starting point you will traverse k items to check how many occurrence of 2 is there. Once it is done, now you will go here, then from here again you will check how many 2s are there. After that, here again, and you will check how many 2s are there. After that, you will come here and again check how many 2s are there. Then after that, you will come here again, check how many 2s are there. You can't go beyond this because the window size won't be fit because there are 2 items only. Correct? So that's how we know, because we have seen it in the previous question. So this would be the time, and space comes to क्या हो जाएगा brute force में? Big of 1. But what are we focusing upon here is, as you can see, हम क्या कर रहे हैं? Repetition नहीं कर रहे हैं. For this very first window, we already knew that there is 2, correct? But moving forward, from the for the rest of the windows, we can clearly see that. Let me write it again. 1, 2, 3, 2, 2, 1, and 2. है ना? For this very first window, we knew कि एक बार 2 आ रहा है. Okay. Now for the rest of the windows, we know that one item is leaving and one item is getting added. है ना? One item is leaving and one item is getting added from here. So if the item left is not 2, we are not gonna decrement the count. And if the item being added is 2, we are gonna increment the count. ठीक है? तो काउंट पहला में कितना था? 1 था. ठीक है. अब नेक्स्ट आइटरेशन में क्या होगा? द आइटम लेफ्ट इज नॉट 2, सो नो इश्यूज, बट आइटम एडेड इज 2, सो ये +1 होके 2 पे आ जाएगा. ठीक. नाउ फॉर द नेक्स्ट विंडो. नेक्स्ट विंडो कहाँ से कहाँ तक है? इट इज फ्रॉम हियर टिल हियर. Which item is getting deleted? ये 2 जा रहा है. So if the item leaving my window is equal to my target item, which is 2, and the target भी 2 है, item भी 2 है. So count -1. So 2 minus the previous count -1 is equals to 1 आ गया. Now look at the item which is getting included in my window. It is again equal to target. So +1 equals to 2 final हो गया. ठीक है. Now go to the next window. If I go to the next window, so I'm here. So the item leaving my window is 3, which is not equal to my target, so no issues. I am not gonna subtract anything, so 0. Okay. So in the previous count, and item added in my window is 1. Again, it is not 2. So +0. Answer 2 ही रह जाएगा. ठीक है. Now let's move my window further. Here. So here, this 2 is leaving my window, and which is equal to target. So previous and occurrence -1. कितना आ गया? 1 आ गया. ठीक है. Now this is included, which is 2. So +1 आ गया is equals to 2 again. So now you can see here, after that, my window can't go any further because there's no items, no more items. So you can see that the output is 1, 2, 2, 2, 2, 1, 2, 2, 2, 2. Okay, that's what we are going to do. So the only thing you need to work upon is counting the occurrences here, because things are similar to the previous things we have done earlier, inside के instead of counting target in each window from scratch, we can maintain a running count. Okay, maintain a running count. A strategy: when window slides right, whenever we are moving the window in the right hand side, if element leaving window, okay, means target decremented, same है ना, and if new element entering means target incremented. ठीक है, just a typo here, equals target होगा ये, is equal to target. Okay, not means. Then you can write means decrement count. Okay, and here entering, if new element entering window is equal to target means increment, है ना, काउंट लिख लेते हैं, काउंट वैसे है वहां पे, ठीक है, means increment count. Okay, that's what is happening, that's what I have shown you earlier. Why this works: we should only care about changes at window boundaries. Internal elements don't affect the count, yes, because those are just nothing more than repeating elements. ये बहुत important है. Okay, so let's see here, though I showed you earlier, but again let's see in the formal way. First window 1 2 3, count target 2 appears one times, result is 1. Next window, slide to 232, अब 232 पे गए तो again living item is 1 which is not target, so count would be unchanged, but here right element 2 is target, so count would be plus 1, so ये अब होके 2 हो गया है ना, so that's why 2. Slide 3, step 3 sorry, slide to 322, अब मैं 322 पे आता हूँ, 3 2 and 2. Okay, this window की बात हो रही है. So here 2 got removed from this window है ना, left element 2 is target, so count -1 किया तो 2 में से 1 गया तो 1 आ गया अभी के लिए, ठीक है, for now. But 2 got added also, so that's why plus 1, so again it have become 2. So till now 3 windows, 1 2 and 2 is the output. Okay, fourth window, let's move to the fourth window. Fourth window is this fellow, 3 left and 1 is added, so no changes in the count है ना fourth window में. So again count 2 था, अभी 2 है, तो 1 2 and 2, you can see that. Now in the fifth one है ना, फिफ्थ वन कहाँ से कहाँ तक है, यहाँ तक हमने किया था, ये हो गया था, देन यहाँ से यहाँ तक है. ओके, 2 1 2, item leaving is 2 and item getting added is also 2, so again count is not getting changed, effectively 2 is there, so 1 2 2 2 2. Okay, that's what the output is gonna be. Okay, so let's see here, this is the implementation. So you can see here n is what we have found here, then result, how many results are going there, again I have written some formula here, you will be thinking sir if it's a formula लिख दिया क्या कर रहे हो. So my idea is simple math, basic math. You can see what is the length of the array. 1, 2, 3, 4, 5, 6, 7. And k was 3, window size 3 था. तो output कितने आए थे? कितने such windows हो पाए थे? 1, 2, 3, 4, 5. And is 7, है ना? And number of windows जो थे आपकी कितने आए थे? 5 आए थे. Yes or no? 1, 2, 3, 4, 5, 6, 7. Yes. इनका रिलेशन क्या है फिर? इनका रिलेशन क्या है फिर? k is 3. So obviously n minus k plus only तो आ रहा है window size. Sorry, total number of windows. Yes or no? Total number of windows is n minus k plus 1. ये तो आ रहा है 7 minus 5 plus 1. Okay. n minus k plus 1. ये आ रहा है? Oh, 3 होगा ना. So n minus 3 4 हो गया, 4 plus 1 5 आ गया, which is equal to this. Okay. So this is how you can calculate total number of कितने windows अभी होने वाले हैं यहाँ पे. Now count is 0. Very first window we are calculating number of occurrences. Then at result 0 count put कर दिया. then rest of the logic. Int I equals to k, I less than n, I plus plus. Element living window would be subtract if it is equal to target. If living item which is I minus k, then if it is equal to target, then count minus minus. Otherwise, element entering the window. If it is equal to target, then count plus plus. Okay. And once it is done, then we are updating our result array I minus k plus 1. सेम लॉजिक से हम ये निकाल रहे हैं, है ना? This you can try on your own. Why or how this formula is coming. The hint would be यहाँ जो फॉर्मूला लगाया था ना n minus k plus 1, तो सब तो n था टोटल एरर को कर देते हैं. अब यहाँ i क्यों है? क्यों? क्योंकि रिलेटिव पोजीशन की बात हो रही. So I would really ask you to try it on your own and figure out how this is happening. Okay. कोई रॉकेट साइंस है, बहुत इजी, जितना पढ़ा है उसी पे है. Okay. Equal to count by updating, and then once everything is over for this for loop, all the windows are done, then we are just returning the result array, which is storing nothing but the count of the target in all the windows of size k, which is 3 here. Okay. So again, if I were to ask about the time complexity, क्या आ रही है? Big of n ही आ रही. Total number of items traversed are n only, nothing more than that. Space complexity यहाँ क्या आ रही है? Big of 1, constant ही है अभी. ठीक है. So I hope this is clear to you, right, people? Or you can write your thoughts in the comment. I can pick up from there later and take your doubts as well. Okay. Now, pattern recognition for the framework. Though we know how we are applying it here, but how would you identify कि कैसे हो पाएगा? When to use basic sliding window, है ना? यहाँ देखते हैं. Once after reading the question, you need to ask these questions, and if the answer is in this flow, then you can probably apply this. So, is it a subarray problem with fixed size k? Agar yes hai, so then do we need to compute something about each window? Yes hai, then can we compute it by adjusting previous results? Yes hai, then use sliding window. Okay, maintain running value सम काउंट एटसेट्रा. ओके, ऐसा कुछ इस पे पॉइंटर्स, मतलब यू कैन से सम थिंग्स मस्ट हैव बीन मेंशन कि हाँ क्या करना है वहाँ पे. सम की बात हो सकती है, काउंट की सकती है, कुछ और की बात हो सकती है. नेक्स्ट है एडजस्ट व्हेन विंडो स्लाइड्स. एडजस्ट करना है कि विंडो स्लाइड कैसे करेगी जब स्लाइड कर रही है. मीन्स प्रीवियस आइटम को एक हटाना है, न्यू आइटम को एक ऐड करना है. एंड ट्रैक मैक्सिमम मिनिमम इफ नीडेड. ओके, सो दिस इज द बेसिक आइडिया ऑफ दिस फ्रेमवर्क. Okay. Now, problems following this pattern. इस pattern कौन कौन से problem usually आ रहे होते हैं? Maximum, minimum sum of size k. K is a window size. Okay. Then average of subarrays of size k, ये भी solve किया. Count occurrences अभी solve किया है. Many string problems with fixed windows भी आती है. string में आप देखोगे. ठीक है. Common mistakes क्या होती हैं? So common mistakes are misses last window. Means remember in the brute force we were writing कि आई से जीरो से स्टार्ट हुआ था, कहाँ तक जा रहा था? ऑब्वियसली एन तक तो नहीं जाता है. ठीक है. तो व्हेन के इज द विंडो साइज गिवन, तो कहाँ तक जाता है? लेस देन इक्वल्स टू एन माइनस के तक जाता है. बट समटाइम्स पीपल राइट लेस देन ओनली, है ना? सो प्लीज डोंट, बिकॉज इफ यू राइट दैट देन यू विल मिस द लास्ट विंडो. लास्ट विंडो मिस हो जाती है. ओके, सो प्लीज राइट आई लेस देन इक्वल्स टू नम्स डॉट लेंथ. मैंने प्रीवियसली एक्सप्लेन किया था कि हाउ इट इज डिराइव्ड, सो यू कैन चेक इट देयर. ओके, first is done. Next mistake is not initializing properly, so might miss the first window. क्या हो जाता है कि int maximum 0 दिया, फॉल नंबर्स आर नेगेटिव, तो इश्यू हो जाएगा क्योंकि तब तो सबका सम ही नेगेटिव में आएगा एंड मैक्स पे कभी अपडेट ही नहीं होगा, है ना? सो दैट्स वाई इनिशियलाइजेशन आपको कुछ कैलकुलेशन के बेस पे करना पड़ेगा. तो मिनिमम वैल्यू पे कर लो या तो एक सम कैलकुलेट कर लो देन इनिशियलाइज करो. ओके. Other thing is wrong index calculation. That's what I was talking about. Here you need to be very, very cautious about your indexes because sometimes you can miss, sometimes you can overshoot also. Index out of bound भी हो जाता है. So that's why by doing the hidden trial, be sure and make yourself very, very comfortable for with these formulas कि कैसे काम कर रहा है. ठीक है. Sometimes people do these kind of mistakes. So wrong index out of bound पहुंच जाएगा. ठीक है. So when this is about when we were subtracting the leaving item and adding the entering item, है ना? So Windows sum minus num psi and plus num psi plus k. ऐसा नहीं था. क्या था? Windows sum minus num psi a minus k plus num psi था ठीक है. This is the item from entering window. This is item leaving window है ना. Item leaving window. So please be careful about these three things majorly. Next is real world application. So let's talk about this. Where sliding windows is used. So network monitoring में use हो रहा होता है, analyzing traffic in fixed time window. You must have heard about this too many times. हैं? जो लोग आप रियल लाइफ में देखो तो बहुत सुनते हो. फिक्स टाइम विंडोज में कोई इवेंट हो रहा है, कुछ हो रहा है. सो ऑब्वियसली एल्गोरिदम बेसिस पर कुछ करना हो तो फिर यही लॉजिक लग रहा होता है. जहाँ पे फिक्स्ड टाइम की बात है तो फिक्स्ड विंडो की भी बात हो रही होती है. ओके. So fixed time window is there. Stock analysis. Those who know about stock, they always know about this that it is all about in what period of time what is happening. So that's a calculating moving averages over periods. Also implements this quality control, monitoring production metrics in real time. Production metrics को real time monitor करें. It is always about time frames. So again, time frames is nothing but a window. Okay. Sensor data, processing streaming data from IoT devices. Again, it is about the time frames. Okay. Now, interview statistics means कहाँ का कैसे आता है. So very common in online test हमेशा तो पूछता है. For Google frequently combined with other patterns means this is a too straightforward, so they will combine it few more problem statements or few more patterns that you need to figure out and solve it combinedly. Okay. Next is a Microsoft, so often appears in phone screening rounds. So I mean, the overall thing is this kind of pattern-based question is always asked in all the all the leading companies, all the farm companies, and all the major companies. Okay, so you can't compromise on this. आपको पढ़ना पड़ेगा, समझना ही पड़ेगा, तभी पूरा हो पाएगा preparation. Okay. Now the homework. So level one, please implement all these problems. थी तो नहीं, दो ही किए थे. With dry runs. Okay. Maximum average subarray and test with edge cases. So, see, interviews आपको यही काम आएगा. Though I have shown you the solution, but thinking about the test case is completely up to you. How much you are putting, how much time you are putting in practice really makes or breaks this thing. Because in real time interviews, you should be able to think of the edge cases, है ना? देखो सोचना है इसको solve करना. Okay. Then level 2, maximum sum subarray of size k. Again, this we'll be discussing later. Okay. Permutation in string. You can try to solve on your own. Advanced fixed window question है. Okay. Or later we'll be discussing it. For now, give it a try. Then mastery. Find all anagrams in a string. Okay. I know that the level 2 and 3 can be a little challenging for people, but that's how people learn, right? You learn the basic thing, you implement it, then you move further, then you move further. That's how you grow. Otherwise, how would you know? Correct? And how would you solve the completely new problem faced in the interviews? Okay. So key takeaways from today's session are sliding window pattern fundamentals. We have completed two different fixed window problems we have solved. Running sum and running count techniques was that complexity optimization from n into k to order n directly, and then step by step driven methodology is what we have seen. Okay. Now about the bigger picture. So you learn to think about efficiency by reusing computations, correct? This mindset is valuable for any coding interview. Why? Because optimization is what? See, brute force क्या होता है? Brute force is nothing but get the job done anyhow. ये इसका आंसर होता है, ठीक है? Next comes optimization. Because though you are getting the job done, but get it done in an optimal way. तो optimization कहाँ से आता है? By looking at what can be avoided to do the job faster. So any kind of redundancy or repetition removal must be done. Okay, here in today's session, that's what we have seen, है ना? Computations को reuse कर रहे थे instead of recomputing, correct? That's how we were able to do things today. So remember, the best solution often comes from asking what work I am repeating and how can I avoid it. Please remember this. This will help you move in the right direction because somehow sometimes people don't know where to look at or what to look at. So these questions answer those things. Once you have the solution, you have good for solution, then try to answer these questions, what to look at and how you can solve it. Okay. So for the next session, we will be discussing about variable size sliding windows. Okay. Today we have discussed the fixed size sliding window. Try to solve this question as well. Longest subarray without repeating numbers, hash map integration sliding window, and advanced pattern recognition. Okay. So please come prepared after solving the at least some of the basic questions that you have learned today, because then only some value would be added for you. Now आप पीछे struggle करोगे तो आगे कैसे सीख पाओगे, right? So every pattern you learn makes you more valuable as a problem solver. So you are building an impressive toolkit because as you can see, आदमी में जो फील्ड होता है, जो वॉर फील्ड होता है, वो क्या काम आता है? जो आप सीखे होते हैं, जो आपके टूल्स चलाने आते हैं, जितना आपके पास गियर होता है, जो बैग होता है, उसमें टूल किट्स होती है, वही से काम आती है. So while learning, you are also collecting all those things. This is more like treat it more like a training for yourself, and all the algorithms, all the patterns that you are learning are part of your toolkit, which you are going to use when you are facing an actual interview. Okay, so that's how you think about it. So, people, that's all for today. If you really like this session and if you find it meaningful and helping you in any of the ways, then please do like, share, and subscribe our channel. Okay, and please do join for the next session. That's all for today. All the best, everyone. Thank you.